For the past few weeks, I've given updates of Beam Therapeutics and I'll continue to do so in this video because of exciting new developments in their base editing. I call this Generation 2 version 1.1. How will this affect us investors? Stay tuned for the rest of the video. In the meantime, here's a quick intro of this channel for new viewers. I've been teaching biology since 2004. On this channel, I hope to simplify and explain the science behind the companies that's driving the genomics revolution, one video at a time. Beam Therapeutics recently published a scientific paper in a peer-reviewed journal, CRISPR. I don't know how the journal did it, but they got the who's who of the CRISPR world as part of the editorial team. Well, mostly, just look at the names. Before I continue, I'd like to remind everyone that I'm a small shareholder in this company and that the scientific paper is contributed entirely by the Beam Therapeutics team. I'll try to remain as neutral as possible, but there are conflicts of interests. Let me start by translating the journal article from alien to English so that you can understand the significance of this paper. I refer to the base editing technology that Beam Therapeutics developed as Generation 2 CRISPR-Cas. This is because it cuts only one strand of the target DNA whilst correcting the mutated base on the other strand back to the original, then letting the cellular repair mechanisms complete the restoration process. This is safer than Generation 1, which cuts both strands. Cutting both strands are a no-no since they lead to chromosomal aberrations. If the Gen 1 CRISPR-Cas technology is the blunt knives found in many Airbnbs that cannot cut anything, Beam Therapeutics Gen 2 technology is the Swiss Army knife. And in this scientific paper, the Beam Therapeutics team just reported the next upgrade to the Miyabi. They've now created a repertoire of improved base editors, which I've termed version 1.1. So what are these improvements all about? The Generation 2 version 1 base editors have a guide RNA that recognizes the target DNA sequence. This recognition sequence is known as protospacer, adjacent, motif. Once recognized, this will draw one of the DNA strands with a mutation into the active site of the deaminase domain that is fused to Cas9 where the base editing occurs. Whilst this is an elegant solution, the potential problem here is that the position of the mutated base has to be in a specific loci with respect to the PAM. Too close or too far, it will not be able to fit into the active site of the deaminase. If it cannot fit into the active site, then no enzyme action will occur, leading to the failure of base editing. So the design of the guide RNA has to go through many rounds, thus taking time. And I suspect testing out Beam 101 and 102 took a long time because of this. In this paper, the Beam Therapeutics team created a library of deaminase versions. This is done by mutating the amino acids lining the active site. Let's digress to talk about the amino acids. Amino acids are the smallest units of a protein. They have a standard chemical structure of an amino group, a carboxyl group, a hydrogen atom, and an R group attached to the center carbon. The R group is variable according to the identity of the amino acid. There are 20 naturally occurring ones. This can be categorized by their chemical behavior, either by being hydrophobic, or hydrophilic uncharged, or hydrophilic positively or negatively charged. In a protein existing in a cytosol of a cell, which is basically made out of water, the hydrophilic amino acids will point outwards and the hydrophobic amino acids will point inwards. So the sequence of amino acids will give rise to a protein of a particular shape. Now, let's put the understanding of the amino acids back into the CRISPR-Cas deaminase domain. By mutating the amino acids within the active site of the deaminase, the Beam Therapeutics team is creating a unique active site different from the original. This way, it can target a differently positioned base from the PAM. Creating a whole library of them, the team can then pick and choose which one is the best fit for the guide RNA containing the target sequence to a new genetic disease mutation. It is like picking the right clothes for the occasion from a wardrobe. Now that's beautiful science. Salute to the Beam Therapeutics team. I'm super annoyed with the unruly behavior from the copycat. And with this announcement, it's like sending rain on their parade. This is an important step forward, let me explain. Now that Beam Therapeutics have generated a library of deaminase with different active sites, the benchtop to clinical trials duration will only shorten. Right now, there are 10. Not too long in the future, it could be 100 or even more. This will begin to open a gap with the competitors, especially the Gen 1 CRISPR-Cas companies. And I'm not done yet. No matter if the copycats force their way into using base editing, because they're going to encounter the same problem that Beam have faced and solved. It's like Beam Therapeutics is always 10 steps ahead. The copycats will be stuck at trying to dodge around the CRISPR-Cas Generation 2 version 1 patents of Beam Therapeutics and are then further delayed with the laborious designing of the guide RNA, with back and forth iterations. Nobody can tell better Seinfeld jokes better than Jerry Seinfeld, am I right? And there's one more thing. The BEAM Therapeutics scientific team has gained my respect because they are showing us that they are continuously working on and honing their craft. This means that the company with its ever-increasing patent portfolio is slowly but surely taking over the CRISPR scene, and they are doing that without having to copy anyone. Not only that, the strategic merger of Guy Therapeutics shows me that the business and the scientific sides are gelling very well. This is really important for long-term survival. Just look at examples of companies where the two sides don't talk to each other. As a small shareholder and a believer, I'm pretty pleased with how everything has turned out so far. Let's start curing genetic diseases soon! For the Watch to the End gang, thanks for spending the time, and I hope that the hard work has helped you in one way or another, either in getting you interested in biology or in helping you navigate the complex field of the genomics revolution. I'll be taking a break and will come back in June because I now need to turn my attention back to my students because their exam season is about to commence. Not only that, creating new YouTube videos weekly is taking a lot of me. Between my full-time tutoring as well as maintaining this channel, it's like 2 careers except that this one does not pay. Sometimes I ask myself, why do I even do it? But then again, if a YouTube newbie like me can start something from scratch, then I hope I can inspire you too. If you'd like to support me, all I ask of you is to continue to tune into my videos or even rewatch some of the older ones too. Maybe you might find something new in the process. I suggest starting with these two, and I'll see you over there shortly.